Hi folks, let's look at the universal gravitational law. It's Newton's law of universal gravitation. Now, the most important thing is the law. You need to be able to state it according to an exam guideline. It says each body in the universe attract other body with a force that is directly proportional to the product of their masses and inversely proportional to the squared distance between their centers. So let's take an example. You have this body and this body. These two bodies, they have the force between the two that they attract each other, and there's a distance between them. That force between them, it's m. Let's say this is body 1, body 2, right? So they have a force. The force that they attract each other, these two bodies, is directly proportional, right? Is directly proportional to the product of their masses. What does it mean? From the Newton's universal gravitational law, the formula is that it's F is equal to G over G. G mass 1 times mass 2 over R squared. The R squared is the distance between their centers. It's a squared distance. We know the force is what? It's newtons, and this G is a universal constant. It's 6.67 times 10 to the power negative 11, and mass 1 and mass 2 masses, they must be in kilogram, and this is the distance between them. It can have the symbol D or R. It's measured in meters. All the time it must be in meters. Now, according to this law, it says this attraction between the two bodies is directly proportional to the product of their masses. Let's look at that. Mathematically, when you write that force is directly proportional to the product of their masses. Now, what does it mean? If you change anything between the two masses, let's say you double these two masses, you double both, that means the mass will be doubled twice. The force will be doubled twice as well. Let's say if you double one, the force will be double because they're directly proportional. Something that is directly proportional, it means the factor that it changes by and the other will change by the same factor. So you double one mass, the force will be double. You double both, so it will be 2 times 2. That makes 4. That means the factor that it will change by the force, it will be 4 times bigger than the original. Okay, let's look at it. Now, graphically, things that are directly proportional, it's a graph like that. It's a product of masses there, and we have the force in newtons. Things that are directly proportional, it's going to be a straight line like that, right? Greater mass, greater force. Now let's say if we want the gradient of this graph, the gradient of this graph is going to be change in y over change in x, and then the gradient, it's very important to understand the gradient. So it will be change in y over change in x. What is my change in y? It's force. And what is my change in x? It's the product of masses. So the force, in order to know what is exactly the gradient, so the gradient, I know it has to do with from this formula we are looking at the relationship between the force and the product, so it has to do with the distance. So if we substitute F by m1 times m2 over r squared, and then all over divide by mass 1 times mass 2. So mathematically, so you have mass 1 times mass 2 over r squared, and then we change this division into multiplication. So this is product of masses over 1. So when we change that into multiplication, it will be 1 over mass 1 times mass 2, and those two, they cancel. So the gradient here, it's 1 over r squared there for that. Now again, the product of forces is inversely proportional to the squared distance. What do we mean by the squared distance? So if the distance between the charges, if I place this and I increase the distance, now it's going to be there. Do you see the distance is increased? The force is going to be weaker. So the more the distance between them, the weaker the force. So they are inversely proportional. So let's look at graphically how that is going to graphically. So here we have what? We have the force in Newton, and we have the distance there. So the inverse proportionality, it's going to be an exponential curve like that, so it doesn't have a gradient. But now let's say if we say the force is directly proportional to an inverse of a distance, so it's going to be a graph like that. It's a force here, and now it's going to be 1 over r squared. So when these two when we say the force is directly proportional to an inverse, so they become directly proportional indeed. So the graph is the gradient is going to be like that. It's going to be a curve that cuts through the origin. Now the the gradient there, it's change in y over change in x, that's the gradient, which is change in y over change in x. Change in y, it's going to be the force over divided by 1 over r squared. So now we're going to replace the f with the formula. F we're going to replace by m1 times m2 over r squared, and then we have divided by 1 over r squared. So the hint, guys, here, in order to get the gradient, if you have the distance and the force, that means the gradient, it has to do with the product of the masses. So these two, mathematically, these two are going to cancel. But let's see. So it's going to be m1 times m2 over r squared, and then we change this division into a multiplication, and then we invert this, so it's going to be r squared over 1. Alright, so what cancel there? It's the r's. The r cancel, you have mass 1 times m2, that's the gradient there. Very important, guys, with that. And with the universal, let's look at the proportionality question. The proportionality question, it's when, let's look at when you double, let's say you double one mass. So this simply means that when you double one mass, it's going to be 2m1 times m2, and the distance remain the same. And the question, what will be the new force? The force, guys, the force always is 1F. The force between the two objects is F, right? So if you double one mass, what will be? So when you do it in the proportionality, you have 2 mass 1 times m2 over r squared. So what will be the new force? So it's going to be 2, and this represent what? F. So therefore the new force now, it's going to be 2F, which means it's 2 times bigger than what? Than F. Remember when I said they're directly proportional, so if the factor which the masses change by is going to be the same factor that the force changes. Now let's say if let's say you double both masses, so it will be 2m1 times 2m, it's times the 2m2. So in other words, guys, this will be 4. The 2 times 2, it's 4 mass 1 times mass 2. So what will be the new force? We want the new force. Originally the force is 1F. So proportionally we say 2 mass 1 times ms2 over r squared. So this will be, there's 2 there, so it's 2 times 2. That 2 times 2 is going to be 4 mass 1 times mass 2 over r squared. And then we change this to F, so the new force is going to be 4F. So that means it's 4 times bigger, the new force. Now let's see now if I double. Let's see now if I double one mass, so it'll be 2m1, and in the other mass I 3 times, so it'll be 3m1 m2, and the distance now, it's not going to be, there's a change in the distance, and I double the distance. So if I double the distance, if I double the distance, it will be 2r. So what is the new force? So the proportionally, so it will be 2m1 times 3m2 over, and then that 2r, you put it inside the bracket and square it. So it will be 2 times 3, it will be 6m1 times m2 over, it's going to be 4r squared. And then we single out that, therefore the new force now, it's going to be 6 over 4, which is 6 over 4f, which is, it's going to be 3 over 2, 3 over 2f, right? So which means this is half bigger, half times bigger, so it's bigger by half compared to the original.